students, this video is going to go over problem number 3 on page 6. So it tells us here that chlorine gas, chlorine's diatomic, is mixed in a 3.205 gram solution of potassium bromide. So potassium bromide is KBr. Solution means that it's aqueous. It tells us that bromine is also diatomic. It's a liquid. And potassium chloride, which if you look at your solubility rules, you will see that it is a solution, aqueous, are produced. So we should balance. So this is a 2, and this is a 2. We're starting with I'm just going to write this here so I don't forget, 855 grams of Cl2, and we're starting with 3.205 grams of potassium bromide. So anytime you're given the starting amounts of both reactants, you're going to have to do a limiting reactant problem, which means we have to do 2 conversion factors going from each reactant to a product. Now, does it matter which product we choose? No, it doesn't matter whatsoever. I always typically pick whichever one is the easiest to calculate the molar mass on. But you can pick either product. In this case, it asks how much of each product we're going to make, so we are going to have to calculate both products eventually. So we're going to start with 855 grams of Cl2. And down here at the bottom, we're going to have to put grams of Cl2. We're going to put the molar mass, which is 70.9. That is equal to 1 mole of chlorine up here on the top. Remember, we're going to try to get to grams of our product. So we have to use moles of Cl2 down here. Once you're already in moles, you're going to be using the coefficients from the balanced chemical equation to switch from moles of Cl2 to moles of a product. I'm going to pick bromine, because I just have to multiply the mass of bromine by 2. Now I'm going to put a mole of bromine down here. I'm going to use 1, not because it's the coefficient of the bromine, but because I'm going to have to be putting the molar mass up here on the top. So bromine's molar mass is going to be 159.8. And when I calculate this, 0.855 divided by 70.9 times 159.8, I should get 1.93 grams of Br2. I'm going to do the same thing, but this time I'm going to start with the KBr. So I'm going to start with 3.205 grams of KBr. I'm going to put grams of KBr down here, and I'm going to have to use the molar mass. So I have to find the molar mass of KBr, which is 119. The molar mass is always equal to 1 mole, so I'll put 1 mole up here. And then once you're in moles, remember the next step is to use those coefficients from the balanced chemical equation, so you can switch from your moles of KBr to moles of Br2. Notice I am using the same product for both of these limiting reactants. I don't want to take chlorine to Br2 and then KBr to KCl, because that is not going to give me a good comparison. I need to make sure I take both of my stoichiometry conversions to the same product to compare. So then I'm going to have moles of Br2 down here. I'm going to use 1 this time again, because I'm always going to put 1 mole on the opposite side of the conversion factor from my molar mass, which is 159.8. So I'm going to go ahead and calculate this. I've got 3.205 divided by 119 divided by 2 times 159.8, and I've got 2.152 grams of Br2. Now at this point, I'm going to compare the amounts that are produced by each of those products so that I can determine which one is my limiting. So whichever one produces the least is my limiting reactant, so that means the Cl2 is my limiting reactant because it makes less than the KBr. That means that I'm going to be able to make 1.93 grams of Br2. And it wants to know how much of each product I can make, so that means I have to do another conversion factor. Now let me ask you, do I have to do 2 more conversion factors since I have starting amounts of both reactants? No, I don't. I already know which one is my limiting. I know that the KCl that is produced is going to be based off of how much Cl2 I have. So I'm only going to do a conversion factor starting at the Cl2 going to the KCl. So this beginning part is the same as we had up in that first stoichiometric conversion. And I'm going to use the coefficient of the Cl2. This time, though, this is where I'm going to switch. I'm going to switch it to the KCl now, because now I'm trying to find out how much KCl I'll be able to make. And then down here, I've got the 1 mole of KCl, because I can only use my coefficient that one time. I've got to figure out the molar mass of my KCl. So that's going to be 74.55 grams. I'll put that up here on the top. So I've got 0.855 divided by 70.9 times 2 times 74.55. And I should be making 1.80 when I round to sig figs of the KCl. So this up here where my box is, that would be my answer, telling me what my limiting was, how much bromine I can make, and how much KCl I can make. So that's how you have to do limiting reactants. So once you know how to do stoichiometry, you should be able to do limiting reactant questions, no problem. So just let me know if you guys have any questions as you work through some of these limiting reactant problems in your packet.